Now, I'm going to try to keep this short. This video will clearly demonstrate something and basically resolve some questions people might have in their mind about my electric dipole, because it would be natural to assume that it's simply radiating the coax, and because it's the same size as a 40-meter vertical, that's why it's getting out. So I'm going to demonstrate why that is not the case. I'll show you, okay? Now, first of all, I am transmitting here at 5 watts, and this is on the electric dipole. The other radio is at 5 watts on the ground plane. Now, I'll jump up to, conditions are not great yet, it's a bit early, it's only nearly 2 in the hour though. A lot of noise on the band. But I'll hopefully get into Hunter Valley, I'll pull that up, and let's see. Now, so this on 7192 is, oops, I'll get this in, right, is the electric dipole. Now she's a little bit down, and at 7193 is the quarter wave vertical, right? So I'll wait for the electric dipole to come back. So just about an S3, and this is about an S4. So very similar results to before, to the previous video. Now, this is where it gets interesting. So, I'm going to take this meter, which is designed to detect in the direction of the E fields. So that means if I stand between two opposing elements, for example, the displacement currents traveling between the elements will energize this meter, okay? So first of all, we'll go to the messy quarter wave vertical. I mean, it's not fancy, but it's fine, okay? I've just used some scrap I had lying around. So I had this old case, so I've used its connector. So it's a center conductor connects to the element, right? The shielded side, I've actually got these wires clamped in under the other connector there, and also I've got a copper ground rod going quite a bit away down into the ground, copper coated, and all of the radials are connected to that ground rod also, right? So this is transmitting, obviously. And now, since this is the vertical element, and this is one of the radials, of course, there's always potential difference. So when I stand, let's say here, on this element, if I point my detector up towards the active element, it should read, because I'm in the antenna. Let's see. Now, can you see that okay? And as you can see, it's reading very well, right? Watch this. I'll wait for it to come back. Now what I'll do is first of all I'll move further along, let's say roughly halfway along the element, right, and aim upward, and you can see I'm in the antenna, right, which is what you would expect from being inside a 40-meter ground plane, a quarter wave. Now I'll stand right at the hot element and wait for it to come back. And as you can see, and if I go close enough, even the lights light up. That's nearly touching it. Okay, now if my antenna is simply a case of radiating the coax and behaving like a quarter wave vertical, then I should get the same reaction, shouldn't I? So I'm going to stand like the antenna's just there. I'll stand here. Let's see, and I'll wait a while. Tiny tickle. Okay, I'll come closer. Only a tiny tickle, and that's to be expected. We can't change the laws of physics. So highly energetic electric field fringing does cause the electric fields to terminate on any other conductors. So that can't be helped. But there you go. I am not in the main field of this antenna system, where I was with that one. Like I said, all the action is taking place between the two Tauruses. Now, I'll now quickly, I'll just quickly check the comparison there. So it's edging over the S3 there, and this one is what? I timed that badly, didn't I? And that's S4, S5, not quite S5, S4. Okay. So yeah, so as before, okay, approximately an F point. Now I'll quickly jump across. Sorry about my terrible camera work. I'll jump across to VK5. It is noisy conditions right now. Things will pick up a little bit later. So, you know, it's been a bit weird, the band today so far. So, get this happening. Isn't she beautiful? Haha. Alright, okay, 7-1. Oh, silly me. Bring that across. Right. So, that's the electric dipole into VK5. These are both running 5 watts. So she's running about, what's that? Nearly an S3. Yeah, about an S3. And then the 40 meter ground plane. It tickled over the S3. So conditions vary, you know how that is, even between two different antennas from the same site. So, back to the electric dipole. See, she's down now a bit. But the thing is, they're in the same ballpark. And now that should resolve any queries. So, alright, I was standing on a radial. How about between two radials? I'm now standing on the ground. What happens? See, I'm in the antenna, and the meter is going off its head, right? Again, over to the electric dipole. I'll come over here this time, very close to the... I'll step it out, okay? So from the coax is coming off a slight angle, and I'll just go 1, 2, 3 steps, and let's see. There's a little bit, but like I said, for this not to happen, I wouldn't have a signal. I am trying to get a signal out there, okay? But as you can see, I'm not in the antenna. So that should solve that. Excellent. Now, I don't think there's any point in me going to the other radio and proving that I'm running 5 watts, because I certainly wouldn't be cranking the ground plane up to 10 watts to show how bad my system is. Okay, 7-3, and thanks for watching. Whoops, I almost forgot to add this section, so I'm just adding it in now. So I've got the radio transmitting again, 7192, 50% power, so 5 watts. This is monitoring in VK5, but I just wanted to show that if I had common mode currents on the coax, which is normal, of course, for a high Z system, though I have a new trick to solve that, then this is where my coax is coming in. Then I would actually, I'm touching it, right? I'm literally touching, I would have readings here. I've got no readings at all from the coax or from the radio, okay? So it's not coax radiation. This should answer all of those questions and doubts and skepticism, which is perfectly natural, of course. 7-3, and thanks for watching.